Hello, my name is Jeffrey. I am here to talk about getting familiar with the React ecosystem. This is Lab Zero's first Lunchdown, where we invite people in and have them grab some lunch, and then we just talk about a topic that is near and dear to our hearts. And I am the front end guy, one of the front end guys here, so I like to talk about React. I'm working with it a whole lot nowadays. Our CEO, Chris, was just up here talking about this same thing to you guys, but since it's part of the presentation and since I'm webcasting this, I thought I'd mention again that we are Lab Zero. We've been around since 2008 in the city, and we work with people of all different types. But did your live stream start? Yes, I just started it. Okay. Yeah, that's why I'm doing this again. Yeah, we work with companies of many different sizes, clients of different sizes and durations and people and what have you. So yeah, that's us. So welcome. Okay, so let's get started. What is React? So React is a JavaScript library for building user interfaces. That's specifically what it says on the site when you go to it. And it's a very easy, very simple, straightforward description of what React is. With React, you've got your rendering app elements, which are grouped into components. So you've got a whole bunch of classes, essentially, which are referred to as components. And every component, at the end of the day, has a render function, which renders out elements. Now, these elements, in many cases, are going to be HTML, because React is most often used on the web. But people might have heard of React Native, or there are other targets into which you can actually render your React stuff. So React doesn't have a one-to-one relationship necessarily with the DOM, the document object model, but that's how we use it, for one thing, and that's how many other people use it. So yeah. They render, they tell their child components to render. That's usually how it works. So what isn't React? React is not a new language. It's JavaScript. It's not a fully featured framework. It's, if you're familiar with the MVC architecture, model view controller, it's really just the view layer. Unlike Angular or other sorts of more wider ranging frameworks, you're free to provide your own model, your own data layer, your own Ajax layer, your own controller idea, all that sort of stuff. React is really just about rendering elements on the page. And so because of that, React in itself is not very complicated. But what do people actually talk about when they're talking about React applications if it's just really React? Usually, well, they're putting together a SPA, a single page application, where React is in charge of rendering everything inside the body. You tack on some sort of state management system that tells React what to render and when to render it. And finally, React, again, is a front-end library, and it's pretty much back-end agnostic. But it's usually paired with tools like, tools that modernize your JavaScript, like transpilers and module bundlers and source mappers and things like that. And React itself can also be used in the back-end. There's this whole idea of isomorphic rendering, where you use React to render in the back-end, your HTML. You also use it in the front-end for the same thing. So, React is simple enough, but it's the ecosystem surrounding it that introduces complexity. So you might have heard some of these terms. It just goes on and on and on, and eventually, your head explodes because you're like, oh, how am I going to know all this stuff? Sure, React might be simple enough, but wow, that's a lot of stuff to learn. Fortunately, Create React App is one of many different little boilerplate libraries or starter kits that make it a lot easier. This one is the most official. It's made by this guy, Dan Abramov, and a team of people who are really just trying to ease your transition into this new world. Create React App has a lot of features. I'm not going to read them all, but it does a lot. So, any of this stuff that you might be familiar with other libraries, other sorts of build tools or whatever, it'll take care of a lot of this for you. Yeah, so, people are taking pictures, people are doing whatever. You'll learn all of this on the site, and you'll learn about what this all does. And if you don't know what it all means, don't worry about it. That's the idea. There are, though, a few things you kind of do want to know before we continue. First of all, you want to know ES5. What is ES5? It's browser JavaScript. If you write JavaScript for the browser, then you're good. That's just the more technical term, ECMAScript 5. You should know about NPM, Node Package Manager, and just Node, being able to install Node on the back end. If you don't have it, obviously, it's very easy to install. The idea of importing and exporting modules is also important. If you're familiar with Node, then you know how that works. Otherwise, we're talking about dependencies, and being able to pull them into different libraries. That's not popping up on the screen, right? No, okay, cool. And you might also want to know what a class is. Object-oriented programming, just about classes and instances and instance methods and properties and those sorts of things. That's helpful going along with this sort of thing. And finally, we're going to be talking about ECMAScript 6 or ECMAScript the future, ECMAScript 2015, 2016, ES6, ES7, a lot of different names for essentially the JavaScript language as it evolves. We're going to be describing little syntax things as we come to them. So what are we actually going to do today? Today, I'm going to take what we got right here. This is some basic HTML and CSS. Some designer here at Lab Zero has created Blab Zero, which is a micro-blogging service. It's a new, fresh idea. No one's ever thought of this before. You type something in the box and it shows up in a list underneath it, right? We got our blabs. How this lives right now is it's just HTML and CSS. I just opened up HTML boilerplate, typed some stuff in, closed it, no JavaScript whatsoever. So what do we actually want to do with it? We want to make it interactive in a few ways. First of all, we want to be able to fill out the form and submit the form. That includes validating the form and being able to count down how many characters you have remaining, because obviously you need a limit in a microblogging service. And finally, you want to be able to list out the blabs that you've added with that form. So three different kinds of functionality, actions. So pretty straightforward, relatively, to do that with React. Only 8 easy steps. Some of the later steps being somewhat optional, but we'll talk about it as we go. So step 1, get started. To use Create React App, it's pretty straightforward. You just install it. You use it to create a structure, and all of a sudden you run npm start and you're good. So this is what we have running. By the way, I'm not really sure if this webcast is going to be showing it, but I do have it running in a different tab. So here we are. Here's our Hello World page. Welcome to React. This is a little Hello World thing that gets you started. So really easy to get started with this thing. You just start editing this thing, and stuff will magically appear on this page as you do it. Okay, step 2, easy enough. Let's incorporate the HTML template into our application. So this is the structure. We've got, if it's hard to see back there, I'll describe it. We've got a public folder, we've got a source folder. Everything in the public folder is static assets. Everything in the source folder is stuff that is going to be transpiled, compiled, linted, what have you, all that sort of stuff. So it starts with a basic HTML file in our public folder, and we just paste in the HTML, the head, the body, whatever, the sort of stuff you'd get from a boilerplate. And then the rest of the app goes into this app component. So an app component, like I was saying before, every component is a class. So we've got this class extends component sort of thing. The component, I've omitted a few lines, but we're importing this component from React and extending it to create our own app class, which has its own custom render function, which at the end of the day spits out something that looks like HTML inside our JavaScript. So how do we have HTML inside our JavaScript? Well, it's not exactly HTML. It's in fact JSX. JSX is a term created by Facebook. They have just a superset or a language that essentially sits on top of JavaScript and allows you to use React in a little bit more of a idiosyncratic, a little bit of an easier way, because you've got stuff that looks like HTML when really behind the scenes this turns into JavaScript. It turns into a whole bunch of React.createElement, React.createElement calls in a big, ugly nest. So making it look like HTML certainly makes it a lot closer to what we're actually going to have here. There are some differences with JSX. First of all, when you render something from a component, you can't render multiple things. You have to render one element. So we have to make sure that every time we're using JSX, we're rendering a single element with its children. So this is just a big div. For those who are more familiar with UX related stuff, semantic HTML, what have you, extra divs for this purpose make me cry. But it's kind of just the way that app level development kind of works. You sometimes have to do that. That's what happens in React. You have to terminate your self-closing tags. If you're familiar with HTML5, you learned you don't have to do that anymore, but with JSX you do. So it's a little closer in that way to XML, XHTML, what have you. And finally, because this is JavaScript at the end of the day, each one of these little attributes is going to be just properties on an object, and you can't use class. Class is a reserved keyword, which we're actually using up here. So instead of class, we use class name for any sort of CSS class that we want to apply to any elements. All right. So so far, if we were to go back to our thing, it would render out, well, what we saw earlier. Let me really quickly change my branch to, oh yeah, 1 second. You don't have to worry about what I'm doing. I'm really just changing my local thing to a different, check out step 3. All of a sudden, here we go. So here's what our app looks like so far. It's just lab 0, just like we saw earlier. Great, but it doesn't work yet. Type into it, press blab, and the whole page reloads itself. Obviously, nothing happening there yet. Okay, so let's talk about state. So state is just data. It's an object, it's an array, it's whatever, and it's accessible as an instance variable when you instantiate your app. So what we're adding here, for those who are in the back, is we've got this constructor method that we're adding to our app, which of course is something that's going to run when it's instantiated. And it goes ahead and adds a big object called state to our instance, this.state. And it's just a big object of an author and our list of blabs in an array format. Pretty straightforward. So our rendering function is going to take this state and it's going to use it in its code. And we'll see how that works on the next slide. But before we do that, I just wanted to point out that we've got this interesting syntax down here. I wish I could zoom in a little bit more, but essentially what we're doing here is we can access this.state from our render function, but we want to take authors and blabs out of it because that's what we're going to use. So we're using this thing called destructuring syntax, where instead of saying const state equals this.state const authors equals this.state authors, const blabs equals this.state of blabs, we just say const authors and blabs equals this.state, and it just sort of explodes it for us, which is nice. Just a little ES6 thing for those who have good enough eyesight to read this whole thing. I'll think about having smaller code snippets in the future. Yeah, so back to our rendering function, we had our section, which had a whole bunch of articles in it, each article representing a new blab. And so now we're surrounding that with these little curly brackets here. In JSX, you can have expressions. Remember, this is just JavaScript when it all comes down to it. So when you want to run just your own JavaScript anywhere you want, you just use these single curly bracket delimiters, and you can just start writing JavaScript within the scope of the render function. So we're taking that blabs thing that we destructured in the previous slide, and we're using the map function to print out an article for every blab that there is. And as you can see here, we're saying that the source is going to be authors blab.author.avatar. We've got username. We've got blab.text, blab.id. A few things that I circled here are some more ES6 things you might want to know about. The first one being that we're using an interesting kind of function here. As you might know, map, array.map takes a function. But we don't actually see the function keyword here like you usually would in JavaScript, in browser JavaScript. Rather, we're using an arrow function, which where on the left side of the arrow you've got arguments. In this case, we just got one argument. On the right side, we have whatever we're returning. So no return statement, no function keyword, none of that. It's basically just input and output, a nice pure function. So that's what's going on there. And then we also have a new kind of string in ES6, a template literal syntax using backticks rather than single or double quotes, which allows us to use little $sign curly bracket in there to interpolate some JavaScript statements. This is not part of React. It's just part of ES6, and you can use it anywhere. these backticks are great. There's really no reason not to use them for any sort of concatenation purposes that you need to do. Yeah.
So blabs came from the state.
It did, yeah. Just real quick, in the previous slide, we have this .state.blabs here, and here's the very beginning of the render function where we are taking blabs from this .state. So yeah. And then we're just going ahead and using it here and mapping it out. Yeah, so worth noting, I think I'll talk about this in a little bit, but this render function will run every time the state changes. So in the case that we make any changes to this .state here, then the render will run again, and we'll see specifically how that happens.
If blabs is null.
If blabs is null, then we'll have a problem,
Okay.
because we expect to be able to get that, and we'll just get a straight up I don't know, type error or a reference error or something, like, you know, mapped is not a property of null, you know, something like that. Cool. So we're done listing out blabs. Now on to the form. Let's talk about controlled elements. So what's a controlled element? So far, if we just switch over back to our thing, we can type into this field and have a great time, but nothing's actually happening. React isn't aware of the fact that we're making any changes to this element. Form elements are uncontrolled by default. You can just throw a text area into a render function and it'll just act like any other text area. But it's hard to get and set the value of that. You know, we need to get the current value to create new blabs. We obviously want to take it and, you know, add it onto our state. We want to be able to clear the field once a new blab is posted. That's another thing. And this is not like jQuery where we can just use some sort of DOM selector to find the element's value and just use it anywhere throughout the entire application. The use and the access of the direct DOM within React is discouraged because the idea is that this could not even have the DOM as a target. You know, we could be rendering to some entirely different thing. So we don't want to do that. So how do we create a controlled element? Well, we're going to be adding a few properties onto our text area field, specifically value and onChange. And when we do that, whatever the value is always what's going to show up in the text area. And onChange is a little listener that will go ahead and hopefully change that value. So just a few more little things that we're adding to app.js in this point. By the way, like if you are interested in seeing, you know, like sort of how this whole thing progresses as we go on, you are free. I'll be listing out. I'll be you know, linking to the actual repository, which is public, and you'll be able to download it and go through it step by step and see the diffs, see exactly what I do at every point. So sorry, I'm really just showing little snippets as we go along, but this is kind of the important additions. So one thing we're adding to the text area's initial value is the actual state, which at the start should be a blank empty string. The text area will be changed to have these two properties, onChange and value. We're using the curly bracket syntax to pass in just JavaScript values here rather than surrounding them in quotation marks. If you're familiar with Angular, you know that you know, those quotation marks are turned into evaluated little statements. Not so in React. You need to have a special sort of curly bracket delimiter to simply refer to actual JavaScript properties or variables or what have you. Another thing that we're adding onto our app is a new instance method called handleChange. And as you can see here, we are calling this.setState, which is a method that comes with the component. It's just built in, and it is what causes the state to update, and then then it's what causes the actual render function to take place. Hopefully, I'm not in the way of any of this. So you know, we're setting it to whatever the new value is. Now, I talked about trying not to access the DOM or whatever, but in the case here, this handleChange event is a real actual like DOM event. So we do need to access the event target value to get the actual value of the string. This is the only place in the entire application, in fact, where we are like, you know, making the assumption that the DOM actually is a thing. We have to get the value from the field somehow. So that's how we're doing it. But once we set the state, then we just access it from the state from here on. Yeah, don't worry about this. Basically, we're passing in this.handleChange, and we'll have some weird definitions of what this is, unless you know what this.setState is, unless we use an arrow function rather than the usual, function, which just prevents binding issues. Make sure that this is always pretty much what you expect it to be, in which in this case is the app instance. Okay, so at this point it's pretty straightforward. We can add a little string right here, app.characterLimit minus text_area_value.length to get the current remaining characters there. Simple, just a little subtraction statement there. And we can also disable the button, disable the submit button. If the text area value length is 0, you haven't typed anything into it, or if it goes over the character limit, then we can set the disabled property to either nothing or disabled based on that sort of thing. So we're just calling this little function inside our little disabled evaluation every time the render function runs. Cool. Where's my mouse? There it is. Okay, so cool. We've got a nice working form. The value is being stored into the state every time we change it. Now let's actually submit the form. Okay, so we've got our onSubmit event listener. Much like our onChange, it's just going to be an actual event. So because this is an event, we need to prevent default. This is the point at which we obviously say, like, okay, this is a single page application. We're not going to leave the page, so let's prevent default here. Then we go ahead and we set state, just like we did earlier. In the previous example, we had set state where we were passing in an object representing a part of the new state. But in this case, we're taking a function. We're providing a function instead, so we can take the previous state and do some stuff with it and return the new thing. A few ES6 notes, by the way. We're using an arrow function here again. We've got this weird parenthesis bracket syntax. This is to make sure that it's apparent that we are returning an object and that we're not using, as you know in JavaScript, the little curly bracket means two things. It means it's a code block, or it means that it's an object, key value pair based on the usage, based on where it is. But here's a little bit of confusion where you can use a curly bracket as part of the beginning of a code block in your arrow function, or you could return an object. So we use parentheses around the object to show that that's what we're returning. And another more interesting part of ES6 is we've got this new spread operator. Spread operator is really cool. It just allows you to essentially explode an array or explode an object into its individual parts and pass it into a new object or pass it into a new array. So what we're doing here is that we're going to be setting the state when we submit a new blab to be a new array where at the very top, remember, new blabs go to the top, not the bottom of the list. That at the very top, we're adding a new object with a new author, new ID, and new text based on maybe parts of the old state or whatever else. Yeah. And then finally, we are pretty much tacking on all of the previous things from the previous array. So instead of doing array.push or something like that, we want to make sure that we're always returning a new object. And doing something like array.push means that we're returning something from before, which can have problems. So there's this whole idea of immutability with React state that we want to sort of adhere to. So we're always trying to return new objects and new arrays every time we make a change. And then finally, of course, we want to clear the text area value. It's as simple as just saying text area value is now an empty string again. Okay, so that was a lot. Are we all done? Well, the problem is now that the entire page re-renders when the state changes. This includes every time we change the text area. Every time we type into it, that render function gets called. But I should note at this point that when I say render, remember that React is somewhat agnostic about whether it's rendering to the DOM or not. And so React's concept of rendering something is that it's got its own sort of, well, what people sometimes refer to as virtual DOM, the idea that it's got its own sort of tree of elements that it has. And it makes diffs, it makes little comparisons every time to see what parts of that whole render tree have changed. And if anything has changed, that's the point at which it actually tells the DOM to update. So it tries to be as efficient as possible in regards to telling the DOM to update, but still, there might be a lot of logic inside a render function. We've got that map function that's going to be iterating through our whole list of things. We've got some we've got some concatenation, interpolation. We have a whole bunch of different things checking whether things are valid or not. And it seems like that's a lot of logic that really doesn't need to run, really doesn't need to happen. In an app as simple as this, maybe it could be very fast, but in a very complicated app where you've got a very complicated structure, you certainly don't want to have to re-render the entire page, even virtually, every time something changes. So what we can start to do is split out components. We can split the state out as well and affect what renders on a component level basis. So yeah, let's add some more components. Let's talk about child components and about props. So yes, an app can be broken up into components. They don't need to know the entire app state. We got this little diagram here where each C is a component and it's got its own little state. Just the way React works though is that when a parent re-renders, its children re-render too. So in this way, it's a good idea to move stuff down to the child state if only the child component needs it. In addition, for child components to know what's happening in their parent, we have props. We're passing down props, which we've seen already in our little code snippets. It's just attributes on an element that are being passed down, different sorts of values. So yeah, this is what our whole DOM will look like, split out into different components. We got our app, we got our form, our blab list, and then our blabs. We give these things, capital letters or capital camel case, whatever you want to call them, title case. That's not it. Names. And so this is how we're going to do it. So let's start with app. This is a lot of code, but I'll point out two specific things that are happening here. Down here in the div, we've got form and blab list with uppercase F and uppercase B. We are now rendering components as if they are just HTML elements. And that's going to cause these components to call their render method as well. So there's that. We've taken the text area value away from this state because only the form really cares about that. We'll see that probably in the next slide. Yep. And but the only problem is that this form does have to know how to add a blab here, because the form needs to talk to the app needs to pass those blabs down to the list. So the app is still sort of delegating between these two sibling components, since siblings really just can't talk to each other. So that's a little strange. Here's our form. Our form has a little thing called prop types on it, a little static class property that says what sort of props specifically the form expects. So as we saw in the previous slide, we had a little add blab thing when we were rendering form, and so this just makes sure that that happens. It's a really great kind of like debugging, bug fixing sort of thing, because it'll just comment out if you've missed something or if something is undefined when it didn't expect it to be, that whole sort of thing. The state is very straightforward. It's just a little object with the text area value. And finally, the submit handler calls this.props.addBlab because that's what's coming from the parent. So this.props is an object that every child component has that comes from whatever its parent is passing down to it. Yeah, so there's that. Then we've got our blab list. Our blab list, again, is being passed down authors and blabs, so we make sure to confirm that that's happening. And otherwise, this has no constructor method. This has no state of its own because it fully depends on whatever its parent is passing down to it. There's no need for the list itself to know, oh, I am a list of some sort, or any sort of local changes have been made. So none of that. And as you can see, it's rendering out a uppercase B blab component for every one. So let's see that on the next page. Inside each blab, again, we're expecting some things to be passed down. Just the author, just the text. We're not passing down the entire object because it really doesn't need it. And otherwise, no other state. This is just where the rest of that HTML went for every article. All right. So, are we all done now? The app no longer constantly re-renders every time we type in the text area because the state is now in the text area. But it is still re-rendering every time a new blab is added. And we're also distributing stuff from the app all over the place. We're passing stuff down from blab list all the way down to blab. We're passing stuff from app down into form. Form is talking to app. there's a lot of stuff going on. Is this really what we want? This is the point at which we're pretty much done with what React can do and where we start to add in some helper libraries. Let's talk about unidirectional dataflow. So again, this is more of a graphical version of what I was just talking about, where this is the way our structure currently works. We've got our app, which passes props down to form and blab. Blab list passes props down to its components. Form calls a function, add blab, which comes from the props, which causes the app to update. So a little bit of direction there. But it seems like there's state in a lot of different places, props coming from all directions, components, passing functions different places. I think that we could simplify this quite a lot. So could we put just state and actions in one place? This is where Redux comes in. Redux is my state container of choice. There are a whole bunch of other ones, but this is mine. It's really probably the most popular one at this point. So let's talk about it. This is what Redux does for you. Redux is a state container for JavaScript apps. The way that it works is that it's got a really big state, possibly the state of the entire application. And it passes props down to specific components that need it. As you can see, there's just one component. The component doesn't really necessarily care about its parents, doesn't care about what it's to its children. The component has direct access to the state. And the state passes stuff directly to the individual components. The components then dispatch actions back to Redux's store, which contains its state, and the whole cycle repeats itself. So component events turn into actions, which cause the state to update, which then pass down new props, potentially, to other components, which cause them to change. This prevents unnecessary rendering because there's no longer a whole render chain of this should render that, should render that, should render that. Well, there still is in a way. I mean, we still have to have this whole sort of like nesting thing where parent components render their children. But it does make them a little more component-y because they're less dependent on whom their parent specifically is. So installing Redux is pretty straightforward. You want to npm install --save Redux, but also React Redux, because Redux, despite its name, does not have to be used with React. I would probably guess that 99% of the time it is used with React. Well, maybe not that much. People do use it with Angular, Angular 2, other sorts of libraries sometimes, because this state container kind of runs parallel to it. The React Redux library is what provides that sort of connection between the two things. So we'll see how that works in a minute. First thing we do is, here we got another big code slide. We create a store. This is pretty straightforward. This is what you've seen before. Just initial state, it's authors and blabs and current author all in one big thing. Down here at the bottom, I wish I'd made this a little bit bigger, but it's basically we're just saying create restore. We're passing in a reducer, which we'll talk about in a second, and this initial state here. The reducer is what's responsible for generating the next version of the state. So every time an action is dispatched, the reducer runs. So we'll see how that works in a little bit. I didn't talk about dispatch, but that's how the reducer runs. We'll talk about that as well. So step one, the entire React application needs to know about this store. It needs to be able to have access to it. So we've got this magical component coming from React Redux called the provider. We're surrounding the entire app with provider. I don't know if I even showed this, but this is index.js, where we're actually telling React to render something onto the page, specifically React DOM, which again is the library that works with the DOM. So you got these two partner things, React itself and then React DOM, which renders into your browser, and it's going ahead and rendering the provider, into which we're passing the store, which we saw in our previous slide, which is really just, I don't know, we'll talk more about that in a second. But the app needs to be surrounded with it so everything inside it can request stuff from it when necessary. So app no longer has any state. We just got rid of this state. It's also worth knowing that we're not passing anything down in the form or blab list anymore. We're still instantiating them, but they're going to be responsible for asking for their own stuff. So form no longer needs any props, blab no longer needs any props, not necessary. So it's a lot simpler there. So simple, in fact, that this could be turned into, well, I'll talk about it later. There's this idea of pure functions, but if I have time, I'll talk about it. Blab list has a new little decorator around it called connect. This comes from that React Redux library. Instead of just exporting the blab list from the blab list file, we're now connecting it to this little connector function called mapStateToProps that takes the state of the entire application and slices it up into specific state values that need it. So that this component needs, specifically in this case, the list of blabs. Don't need authors at this level because all we're really doing is using the list of blabs to map them out, just one after another. The code now looks like blab ID. We don't need, at the blab list level, we don't need to know what the text of each one is. We don't need to know what the author of each one is. That sort of stuff is not necessary because every individual blab is going to request the information it needs. But each blab does need to know specifically what its ID is. So let's see how that works. Blab also has its own mapStateToProps method, and it also gets passed in own props, which are what the actual thing from the previous thing, the ID that is, are. So we have to go through the entire list of blabs here from our state and find the one into which the ID that's passed down matches the one from the state. That's a little strange, and we'll get back to that in a second. Because the idea is that because every individual blab, all it knows is that it's got an ID, it needs to iterate through this whole array of blabs to be able to match what ID matches up. And that's if you're familiar with big O notation, it's O(n)², which is a little more complicated than it needs to be. So we can fix that in just a second. But at the end of the day, this mapStateToProps returns just the author and the text. That's all that's necessary for the blab to render. And we decorate it, and there we are. Our form has a different thing. Instead of mapStateToProps, it has mapDispatchToProps. Dispatch is a method that any component can request, and it is when called, it is what causes the state from Redux to change. So every component has the ability to change Redux's state at any point. All it needs to do is access dispatch. What's dispatched, though, is not the specific instructions on how the state should change, but it's just a little object that contains a type of something. So now we've got this concept of actions. They've got names, such as add blab. Sometimes they contain a little bit of payload along with them. In this case, text. Instead of saying text:text, we're just saying text, which is a little shorthand. And so we make sure to pass in mapDispatchToProps as the second argument of connect, because the first one's always going to be that mapStateToProps connector. So connect has four arguments entirely. We're not going to talk about all of them, but the point to take home is that every component can now ask for state from the Redux store, and it can also ask for the dispatch function from the Redux store, which can cause that state to change. So we talked a lot about this dispatch thing and about the state changing, but we haven't seen the actual logic behind changing the state. So this is what our reducer is, and this is what we pass into the store when we create it. It takes the previous state and returns the new state. So we can take that, what used to be that add blab function in app, which changed the app state, and now we're doing that same sort of thing here. We're adding a new blab to the top of the array here. We also want to make sure to return the rest of the state in case we've got stuff other than blabs. So we use that spread operator for this object to make sure that we're returning the list of authors, the current author, like we had earlier, but also this new array of blabs. So in the case that the action that's been dispatched has a type of add blab, like we saw on the previous slide, we return this as the new state. Otherwise, we just return the old one and nothing happens. And no components re-render. It's the same as it was. So there we are. Okay, so at this point, every component is pretty much independent. They don't really need to talk to each other that much other than the list that passes down an ID for each one. We're almost there, but that problem is that mapStateToProps runs every time the state changes. So again, even every time the text area update. sorry. Yeah, every time the text area updates, that map state to props that's surrounding every single component now has to run. And fortunately, they're very efficient functions. They're usually just returning a new array. But there is that one that has to iterate through every blab to find the correct one with the correct ID, that O(n) squared stuff. So let's try to fix that problem. Let's normalize our list. Step 8, final step, almost done. We want to install another library called Normalizer. So remember, our list of blabs is an array of objects. Each object has an ID, 1, 2, 3, whatever. Actually, I think it's 2, 1, 0 because it goes in reverse chronological order, right? So what we do instead with this blab list here is that we pass it into the state as a normalized list. We have this new thing called schema. We don't have to worry about it. We just need to give something a name. But this is what happens when we normalize this list. It takes an array of records and transforms it into two separate things, entities and result. This makes it so we don't have to iterate anymore. If we need to find the order of our blabs, then we just look at result, which is an array of IDs, 2, 1, 0. If we need to access a specific blab, we take a look at our entities object, which has index 0, 1, 2, each one of which is an object. So now instead of having to iterate to find the correct one, we've just done it once and we're good. And in case the state changes later, then, well, it gets a little bit trickier. This is the point where you don't have to read every single line here, but we've got a lot of spread operators, dot, 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 where we're trying to add a new blab and we have to make sure we add the correct one into our entities list and also to our result list so we can get the right, so it's a little ugly. If you don't like this, if you don't like how this is all looking, there are other libraries that can help out with this. This is where immutable JS comes in. You might have heard of the term immutable, where you've got these sorts of structures that whenever any change is made to them, you can be 100% sure that the structure returned is going to be a new thing, that you're not mutating, making any changes to old objects. There's also React Add-ons Update, which kind of does it a little bit simpler. It does deep modification of specific stuff, so you don't have to do all this spreading at every single level. Return a new array, which returns a new object, which returns a new array, which returns that. Kind of makes that stuff a little bit easier. But yeah, I'm not going to get into that. It's worth knowing about them. So now that we've split it into both results and entities, we can just iterate through our list of blabs at O(n), state blabs, entities, blabs. We're just accessing it, and that's great. Now for every blab, we just need to get the one from that object, the entities object, and we're all good. An alternate thing that you might want to know about is a library called reselect. Reselect does something, well, it makes things more efficient, like Normalizer can. But reselect allows you to derive and store data. You can memoize the result of something. And as long as the inputs, in this case blabs and ID, stay the same, then the next time you select a blab by its ID, then you don't need to go through that whole list again. It's also useful, it's very, very useful for sorting, filtering, reducing, that sort of thing, where if you have some sort of filter set, or only show blabs from one person, or show them in reverse, or in chronological order instead of reverse, or whatever else, you can store that data so you don't need to iterate through in a certain way every single time the state changes, and certainly every single time the render function happens. So that makes it a little nicer too. Reselect can speed that up. And that's it. We've got our 4 components. Redux keeps our store in one place. We're preventing re-rendering whenever unnecessary. And Normalizer has helped make it so even though we've got a more complex state that, well, we know when and why and how. So we're done. Let's think about next steps though, because we've got a few more things we can think about at this point. One thing is that you want to write tests, obviously. We write tests for everything we do. Unit tests, integration tests, a whole bunch of stuff. In this case, writing unit tests is very straightforward and very easy. Create React App comes with Jest, which is Facebook's own JavaScript testing framework, which is kind of React focused, but you can just as easily use Mocha or Jasmine or whatever else you want to use to test out your individual things. There are these render libraries that make it easy to see, like, I don't want to render out my whole tree. I just want to see if this component returns exactly what I want when I render it out. So this makes it pretty straightforward to use. You also might want to connect with the backend. Obviously, we're not running in a vacuum here. At the very least, you'll probably want to run some AJAX. So we want to talk about asynchronous functions, asynchronous actions. When you dispatch something, the state changes. But you might want to dispatch something saying, hey, I'm going to be making a request, so hold tight, and then dispatch something else saying, here's my new data from my AJAX request. Redux Thunk is certainly the most straightforward. It allows you to dispatch functions rather than objects, which get run and then other stuff can get run. It's kind of like callbacks, pretty straightforward. But there's also Redux Saga for Epic, or for Saga, and Redux Observable for epics. This gets a little bit further into the reactive programming thing, where you have this concept of side effects, which I'm not really going to get into. I'm actually very, very new to it myself. But there are a lot of different ways that you can deal with asynchronous things, callbacks, promises, observables, what have you. There are a lot of different ways around that. Also, making XML HTTP requests in the DOM is often very cumbersome. Fetch is a polyfill that will eventually be part of browsers. It just makes it easier to, make an AJAX request and get a promise in return and be able to resolve that promise. Otherwise, you can also use RxJS, which uses observables, and I'm not even going to talk about that, but it's another way of doing the same thing. Finally, if Create React App doesn't serve your needs, if there's more stuff that you need to do, if you're familiar with Webpack, which is its JavaScript bundler and transpiler and whatever else, you want to make changes to that, you can run npm run eject, and now all of a sudden you have everything that's happening behind the scenes. You have your Webpack config, you have your ESLint config, you have your Babel config, you have all these different sorts of things that you can change around. Why would you want to do it? You might want to, again, customize Webpack. You might want to integrate with the backend a little bit more thoroughly, which might be hard using some sort of starter kit like this. You might want to implement CSS post or pre-processors, use CSS modules, use Sass, or you might want to, like I said, customize ESLint or Babel. But there's no turning back. Once you eject, it's a one-way street. So like stuffing everything back into Create React App might be difficult. So that's it. Everything that I've done here, I've got those 8 steps just in the form of different branches. You can just git check out step 1, 2, 3, 4, 5, 6, 7, 8, and see how it progresses. You can use the compare tool on GitHub if you want to see specifically what I've done at every step. That'll certainly walk you along, and hopefully this slide presentation will help you understand why it's all going on. And I think that's it. So thanks for joining in and watching and all that. All right, and I'll see everybody online. Goodbye.